So we have to start the answer. The first question is mechanical power is represented by P equal to F into U plus A V cube into rho, where F is the force, V is the velocity, A is the area, and rho is the density. The first question is the dimensional formula of power. So what is the dimensional formula of power? Power equal to work divided by time. Power equal to work divided by time. Then what is work? Work is same as force into displacement. Work is same as force into displacement divided by time. Then what is force? As per Newton's second law, force equal to mass into acceleration. Force is mass into acceleration, then into displacement divided by time. So now we can write the dimensional formula. Dimension for power equal to dimension of power equal to mass is capital letter M, acceleration L t raised to minus 2, displacement is one length, so it is L divided by time, which is equal to M. L into L become L square. This is t raised to 1. Then t raised to minus 2 is the numerator. If you transfer the denominator t to the numerator, it becomes t raised to minus 3. So the dimension of power is M L square t raised to minus 3. Okay. Now the B part is check the dimensional validity of the above equation. To check the dimensional validity, we have to find the dimension of left side and right side. We have two terms. We have to find the dimension of each term. If all the terms have the same dimensional formula, then we can say that the given relation is valid. That is dimensionally correct. Then what is the left side LHS? In the second question, LHS equal to left side is power, right? Power, clear, right? So dimension of LHS equal to dimension of power is ML square t raised to minus 3. Just now we derived, right? Dimension of power is ML square t raised to minus 3. In the right side, we have two terms, F into U and another one is A into V cube into rho. So what is the dimension of that one? A into V, F into U, right? First, F into U. Dimension of F into U. Dimension of F into U means dimension of force is mass into acceleration. F is force, right? F is given as force. So what is force? Mass into acceleration. So M into L t raised to minus 2. And what is U in the question? U or V? V, right? V is the velocity. Velocity is L t raised to minus 1. So what is the dimension of this term? F into U. It is same as M L square t raised to minus 2 minus 1 become t raised to minus 3. So this term is same as the LHS. And what is the next term? A V cube into rho. So dimension of A V cube into rho equal to, what is A in the question? A is the area. area means side into side, that is L square, length into length. Then what is V? V is the velocity. V is the velocity. Velocity means L t raised to minus 1. So V cube means L t raised to minus 1 whole cube. Then rho is the density, right? Rho equal to density. What is density? Mass by volume. Mass divided by volume is called density. So dimension of density is equal to mass is m, volume is side into side into side, that is L cube. So dimension of rho equal to m divided by L cube. So it become L square, L raised to 3, t raised to minus 1 whole cube, t raised to minus 3, m divided by L cube. So L cube we can cancel. Clear, right? So it is L square. In the MLT form, it is m first, then L square, then t raised to minus 3. So all the terms are same dimension, right? The left side is dimensional formula m L square t raised to minus 3. Right side we have two terms. The first term is m L square t raised to minus 3. And the second term also m L square t raised to minus 3. So we can say that the given equation is dimensionally correct. Okay. The given equation is dimensionally correct. This is the answer for first 1 and 2. Okay. The second question. Give the examples for the following. A dimensionless, unitless physical quantity. So dimensionless, unitless physical quantity, we can write relative density, relative permittivity. Relative means if numerator and denominator is cancelled, right? Relative density, relative permittivity, etc. And coefficient of friction. These are dimensionless, unitless physical quantities. And what about B? A dimensionless physical quantity but having the SI unit. Clear, right? So it is angle is a dimensionless physical quantity. Angle has SI unit radian, right? And if it is angle or solid angle, both are same. Clear, right? Solid angle also. Solid angle. Plane angle and solid angle. What is the SI unit of angle? It's a dimensionless. SI unit of angle is radian. And SI unit of solid angle is steradian. SR, steradian. That is square radian, radius square of radius, that is steradian, R square. Clear, right? So then what is the third one? Two physical quantities which have same dimension, that is pairs, right? Work and energy are pairs. Clear? Both are same dimension, work, energy. And we can work and torque, stress and pressure, and another one surface tension and surface energy. These are physical quantities which have same dimension, that we can normally we'll call it as pairs. Okay. And the third one is pick out the fundamental units from the following: second, meter per second, Newton and Joule. So we have to find select the fundamental unit. Clear? We need to select the fundamental units, right? What are the fundamental unit? In fundamental units are fundamental units. Mass is fundamental unit, right? Mass, kilogram, and length is meter. Clear, right? Mass, kilogram, length in meter, and time in second, and electric current ampere, thermodynamic temperature is Kelvin, amount of substance mole, luminous intensity candela. Clear, right? So in the given example, which is the fundamental unit, it is second. Clear, right? So it is in second. Meter per second, Newton, these are derived unit. Clear, right? What are the other two supplementary units? Plane angle, radian, and solid angle, steradian. That are in supplementary units. For in this question, the answer is second is the fundamental unit. Okay. And the fourth one, significant figures determine the accuracy of the measurement for the physical quantity. The radius of a sphere is given by r equal to 1.03 meter. How many significant figures are there? So we have this 0 is in between non-zero numbers, so the 0 is significant. So we have three significant figures. Clear, right? Three significant figures, 1, 0, and 3. All are, this 0 is lie between non-zero digits, so it is significant. So total number of significant figures is 3. And in the fifth one, the correctness of equation can be checked by using the principle of homogeneity. Clear, right? We can check the correctness of the equation by using the principle of homogeneity. Then we need to state the principle of homogeneity. What is the statement of principle of homogeneity? Principle of homogeneity in an equation containing more than two terms the dimension of each term, the dimension of each term must be the same. If it is same, we can say that the given equation is dimensionally correct. That means dimension of each term of the dimensional equation on both sides, left side and right side, if all the term is same, then we can say that the equation is dimensionally correct. That principle is, we call it as principle of homogeneity. Now, what is the second part of this question? Using this principle, that means principle of homogeneity, check the dimension for the following equation. The left side is half mv square, that is kinetic energy. Clear, right? LHS equal to half mv square. So dimension formula of half mv square is, the constant does not have dimension. Mass is m and velocity L t raised to -1. V square is whole square. Clear, right? Which is equal to m L square t raised to -2. This is the dimension for half mv square. Then what is the right side? RHS. RHS equal to mgh. This is the potential energy. Clear, right? So dimension of potential energy mgh equal to mass is m G is acceleration due to gravity. That means G is acceleration. Dimension of acceleration is equal to Lt raised to minus 2. So instead of G, we can write Lt raised to minus 2. Height is some distance, length L, which is equal to m L square T raised to minus 2. So dimension of left side and right side both are same, and the equation is dimensionally correct. Now we can solve the sixth one. The sixth question is, a company manufacturing PVC pipe claimed in an advertisement that the volume of water flowing through the pipe in a given time is as per the equation V equal to K A square UT. So what is the equation? V equal to K A square U into T, where A is the area of the cross section of pipe. So A equal to area of the pipe. Area. A is the area. U is the speed. That means U equal to velocity. Clear, right? U equal to velocity or speed. T is the time. T is the time. And K is a dimensionless constant. Clear, right? K equal to dimensionless constant. Then what is the question? Name the principle that can be used to check the dimensional correctness of the equation. So we can use the principle of homogeneity. Principle of homogeneity. The second question is, check the equation and state whether the claim is correct. What is the claim? This advertisement that volume of water, volume equal to, V is the volume, right? What is V? V is the volume. V equal to volume. Volume of the water flowing is same as K into A square into U into T. This is the claim in an advertisement. We need to check the statement is correct or not. Okay. So we can check this one, right? What is the dimension of volume? This is LHS equal to dimension of volume. Volume equal to L cube. Clear, right? L cube. This is the dimension of left side. What is the dimension of right side? RHS. K is dimensionless physical quantity. A is the area and its square. U is speed. T is the time. So K does not have dimension. Then what is area? Area is equal to L square. So it is L square whole square. And U is the speed velocity L T raised to minus 1. And U is the time, dimension T. Okay. So which is equal to L raised to 4 into L into T raised to minus 1 and T raised to 1 become 0. Clear, right? T raised to 0. So it is equal to L raised to 5. So left side dimension shows L cube, right side dimension shows L raised to 5. Both are different, right? The claim is not correct. That means the claim is not correct. Now we can solve the seventh one. To measure the distance, we use different units. Clear? Which of the following is the largest unit of length? Kilometer. Astronomical unit is used to find the distance between two planets, right? Light year is light travel in 1 year. And parsec is used as 3.26 light years. Clear, right? What is parsec? It is 30 trillion kilometer. Clear, right? Not billion, trillion. Trillion kilometers. It is approximately 3.26 light year. Light year. So this is the largest unit to find the measurement. Clear, right? To measure distance, we use different unit. Which of the following is the largest unit? It is parsec. Clear, right? One parsec is same as 3.26 light years. Then eighth one, which of the following measurement is more accurate? Is 5.00 kg. This one, right? So which one has this one is 5 digit, right? So we can say that 500.00 kg. There is one unit is here. Is more accurate because it contains more significant figures. Clear? There's 5 significant figures, right? Okay. And the ninth one is a boy recalled the relative mass wrongly as m equal to m0 divided by root of 1 minus v square. Using dimensional method, put the missing c at proper place. So by using the dimensional analysis, already the equation is correct, right? The c is wrongly substituted. Clear, right? Missing c is missing. So as per dimensional analysis, clear, right? As per dimensional analysis, dimension of left side must be same as dimension of right side. So left side is mass, right? Right side also mass. So we have to cancel this v square. Then only it become left side and right side both are same dimension. So in order to cancel this v square, we c also mention as speed, right? So we have to cancel this v square. We have to put the c is below this v. That means m equal to m0 divided by root of 1 minus v square by c square. If you use like this, dimension of v square is cancelled with the dimension of t square. So velocity and c also velocity, the dimension become cancelled. Once v square and c square dimension is cancelled, the left side dimension m, right side dimension also m. So it become the correct equation. So we have to put the c in below this one, right? So v square by c square. So that is the answer. And the 10th one, it is given that E, J, M and G denote the quantities of as energy. Clear, right? E equal to energy. E is same as energy. And J, angular momentum. And M, mass. M equal to mass. And G, constant of gravity. That means gravitational constant. Gravitational constant. This much information is given, right? Then we have to find the dimension of P in the formula P equal to E into J square into M raised to minus 5 into G raised to minus 2. So we can find the we have to find the dimension of P, right? So to find the dimension of P, we know that we have to find out the dimension of energy J square M raised to minus 5 and G raised to minus 1 by 1 we can find. Clear, right? Dimensional formula of E. E is the energy, right? Energy is M L square T raised to minus 2. And next one, mass. E, right? E is equal to J square. What is J? J is angular momentum, right? J equal to angular momentum. Angular momentum means linear momentum into radius. Linear momentum into radius, right? Angular momentum. This same as P momentum into, it is a radius, then a circular motion. Instead of distance, it is, we can take it as R. R is distance. Clear, right? Momentum means mass into velocity. Momentum means P equal to mass into velocity, right? So mass into velocity into radius is some distance. Clear, right? So what is the dimension of J? Mass is M and velocity L T raised to minus 1. Distance is L. Clear? So which one equal to M L square T raised to minus 1. M L square T raised to minus 1 is the dimension of J square. J. And M is the mass, right? Dimension of mass equal to M. And next one is G. G is gravitational constant, right? So what is gravitational constant? We studied in the 9th standard, right? F force equal to F equal to G M1 M2 divided by R square. So if you cross multiply the R square here, F R square equal to G M1 M2. G is the gravitational constant. So we can find this G equal to F R square. The multiplied M1 M2 become division M1 M2. So the dimension of G equal to force is mass into acceleration, right? So M L T raised to minus 2. Radius square. Radius is one length, so it is L square. Mass is M. M1 or M2 also mass, it is M. 1 M we can cancel. So which is equal to M raised to minus 1. L into L square become L raised to 3 and T raised to minus 2. This is the dimension of acceleration, this gravitational constant. G equal to M raised to minus 1 L cube T raised to 2. T raised to minus 2. Okay. Now we can apply this dimension here. Left side is, we can find a P, right? Dimension of P. So what is the dimension of P? Dimension of P equal to E into, E means M L square T raised to minus 2. J square. What is J? We obtained as M L square T raised to minus 1. Minus 1. L square means it's square. M raised to minus 5. M is mass, right? M raised to minus 5. G raised to minus 2. So into M L cube T raised to minus 2 whole square. All raised to minus 2. So dimension of P equal to M L square T raised to minus 2. If you square this one, M square L raised to 4 T raised to minus 2. M raised to minus 5 into, what is the product of this one? M raised to minus 2 L raised to 3 all raised to minus 2 means L raised to minus 6 t raised to minus 2 whole square is t raised to positive 4, which is equal to m cube. Then this is cancelled, right? M L square t raised to minus 2. Then m L square t raised to minus 1 whole square. That is m raised to 2 L raised to 4 t raised to minus 2. Then m raised to minus 5. This is g raised to what is the formula? G raised to minus 2, right? G raised to minus 2 means this one. What is G? M raised to minus 1, right? And I is here it is G. M raised to minus 1. Here it is minus 1. M raised to minus 1 L cube t raised to minus 2. So n raised to minus 1 all raised to minus 2 is m raised to positive 2. L raised to 3 all raised to minus 2, a raised to m all raised to n is a raised to m into n. So it is L raised to minus 6. Then minus 2 into minus 2 become t raised to 4. So which is m square is m cube. Then m raised to 2, m raised to 5. And here is m raised to minus 5. So it is m raised to 0. And L square into L raised to 4 become L raised to 6. And here it is L raised to minus 6. If you add, you will get L raised to 0. And t raised to minus 2, t raised to minus 2 become t raised to minus 4. And here we have t raised to plus 4. So it has t raised to 0 also. That means P is a dimensionless physical quantity. So what we can say, therefore P does not have dimension, right? So P is a dimensionless physical quantity. It's the final answer. Okay.